Video, I will be doing a lesson on the Pythagorean Theorem. The Pythagorean Theorem, you might remember from middle school, is c squared equals a squared plus b squared. Sometimes you might see it as a squared plus b squared equals c squared, which is the same. But notice down here I've got PT for Pythagorean Theorem. The Pythagorean Theorem is used to solve for the length of a leg or the hypotenuse when given the length of the other two sides of a right triangle. So you may want to just hit pause at this moment to record, to write this down in your notes, and then resume. Specifically, a right triangle means that you will see a box in one of the corners of the triangle. So what do we even call the other sides of, or all the sides of a right triangle? So you may remember that this right angle forms is formed when two perpendicular sides intersect. This meaning that, again, this angle is a right angle. And these have specific names. These are called legs of our triangle, a leg and a leg. The hypotenuse will always be the side opposite the right angle. So it's the side that does not connect to form this perpendicular angle here. So I drew two other triangles to show you that when we are finding the hypotenuse, just recognize that it's always the side opposite the right angle. And that will always be what we label C. So again, this is our hypotenuse, which we generally then label either leg A or B, it does not matter which, in the hypotenuse C. So again, for these, the hypotenuse here would be C, and the other two, A or B, it does not matter which. So we can use this to find the hypotenuse or a leg. So I want to come down here and specify that to find the hypotenuse, c squared equals a squared plus b squared really means that it's the hypotenuse squared equal to one of the legs squared plus the other leg squared, which we usually denote by sometimes a subscript, maybe 1 or 2. So I'll say leg 1 and leg 2. When we plug in our leg values into this formula to solve for the hypotenuse, we then need to take the square root. So that means the length of our hypotenuse will always be the square root of whatever this number is. Okay? So in other words, C, while c squared equals a squared plus b squared, C will equal the square root of our a squared plus b squared value. So you're welcome to use this formula, but I want you to be careful about how you type it in your calculator. To find a leg, we're going to take this c squared equals a squared plus b squared and manipulate it a little bit. So I can subtract one of my legs over. So say I subtract a squared from both sides. That will allow me to solve for one of my legs. So c squared minus a squared equals b squared, which we can also turn that around, of course. So b squared equals c squared minus a squared. But it will always be, to find a leg, we do hypotenuse squared minus the other leg squared. And then similar to what we did over here, we take the square root. So leg will always equal the square root of the hypotenuse squared minus one of the legs squared. So this formula here really is the same thing as saying a squared equals c squared minus b squared, because it really doesn't matter which side we denote as a or b. So if you're looking at that and you're going, that doesn't really make a lot of sense, really I just need you to remember this right here. Okay? That we will start off with leg squared equals, and then whatever the hypotenuse squared is, minus the unknown, or excuse me, minus the known leg squared. Okay? So we're going to use this formula where we do hypotenuse squared minus leg squared, and then we take the square root. Okay? So it could be either a or b equals the square root of your hypotenuse squared minus a leg squared. So similar to here, to find the hypotenuse, C will equal the square root of the sum of the squares of the legs. And to find a leg, it will be equal to the square root of the difference, the hypotenuse squared minus a leg squared. So next we're going to go ahead and go over here to Delta Math and talk about problem 1. So as a heads up on today's assignment, there are 18 problems. I will be working 6 of them out with you. So I'm going to work out these first 6, which in that order they then appear. So number 1 is like number 7 and 8. So I put up here, if you notice it says like number 1. These 2 are like number 2. These 2 are like number 3, 4, 5, and 6. Okay, so you know what example to go back and look at. So heading over to problem 1, our job is to find the exact length of the third side. So let's call this, because you have to turn in a picture of all this. Delta Math, today's date is the 9th. Pythagorean Theorem. Always label your work. That way when you go to test, you'll know what that lesson was about, okay, and what that work pertains to. So I'm not going to do this every single, well, I will for the examples. If you are comfortable with not having to write the pictures for all of them after number 6, I'm okay with that, but certainly when you go back to do a quiz or test, it's helpful to have pictures, right? So I recommend that maybe you do that. So 72 and 65, these are the lengths of our legs, not the hypotenuse. Our hypotenuse is the side opposite the right angle over here, and that's our job. And remember, we said we'll label the hypotenuse C. So if you think back to your formula, C squared equals leg squared plus leg squared. And then I'm going to type that in, find the value, and then just take the square root. So I'm going to use my phone calculator, since that's probably what you're going to use. And I'm going to type in 7 squared. Let me try to focus it a little bit. 7 squared plus 65 squared. Sorry, it's going to get blurry. 7 squared plus 65 squared. And that value is 4,274. So I'm going to write C squared equals 4,274. And then we take the square root of both sides. Remember why we do that, though. Taking the square root is the inverse of squaring, so these operations cancel each other out. So now I'm just going to hit second x squared. And I can actually just, if you're using this app, you can tap that number, or you can just type in square root 4274, hit enter. I did that earlier too. 72 squared. Sorry about that. Please forgive me. C squared equals 72 squared plus 65 squared. So I'm going to get a large number here. Sorry. 72 squared plus 65 squared. And I get 9,409. So sorry about that. Second square root of that answer gives me 97. And that's it. The length of my hypotenuse would be 97. I didn't realize I didn't raise that up, guys. Sorry. So there's 97 for you. Ignore this work here. So I'm just going to go over here and type in 97. Notice it does have a square root down here, and it does say find the exact length. That's going to be really important because each of these problems, on the first one, you get an integer solution. The next time, we're going to get an irrational solution, which means it's going to have a square root. And then the next one, it's going to say rounded. So we definitely need to be careful, okay? And that's correct. So on to number 2. So again, paying attention. Find the exact length of the third side. And when you take a look, you notice, oh, I need the hypotenuse. So over here in our notebooks, on our paper, we're going to draw another right triangle. Fill in the given information. So we know that one leg is 6 and the other is 3. And we want the exact length of the hypotenuse. So again, hypotenuse squared equals leg squared plus leg squared. So hypotenuse squared equals 6 squared plus 3 squared. So in my calculator, oops, I'm going to type in 6 squared plus 3 squared. I always have to readjust the camera angle. I wish I didn't have to do that. So 6 squared plus 3 squared is 45. And then we're going to take the square root of both sides. Normally we would say, and notice that is not a perfect square. Normally we would say simplify this. In Delta Math, they do not have you simplify it, so it's totally appropriate to just go ahead and type in the square root of 45. Okay. Notice if you're also struggling with any of these guys, please remember that we have this set up so that you can click on Show Example and over here Watch Help Video if for some reason you needed another example worked, okay? So again, number 3, but notice the instructions. Now it says to find the length of the third side to the nearest tenth. So that means after we take the square root, we're going to write the value of that decimal rounded to the 10th place. So number 3, another right triangle with lengths of 5 and 4. Again, I'm trying to find my hypotenuse C. So C squared will equal 5 squared plus 4 squared. When I type that in, 5 squared plus 4 squared is 41. When I take the square root of both sides, I get the square root of 41. And if I were to type in square root of 41, we would notice it is not a perfect square. We get a decimal value. So let me show you here. So I typed in 5 squared plus 4 squared, which was 41. I take the square root of 41, and I get about 6.4. So one number after the decimal, remembering that if that number in the 10th place, or 100th place rather, had been a 5 or higher, that 4 would round up to a 5. But because it's below, this 0 is below 5, we leave this 4 the same. So we are going to approximate that at 6.4 and type that in. Okay. So next, so those 3 problems are on finding the hypotenuse. Now I'm going to switch gears, and for 4, 5, and 6, we are going to be finding the length of a leg. Okay. So this is number 4. Remember I said I'll do 4, 5, and 6, and then you'll practice 2 of each. But you'll know exactly which problems to go back and look at. So here they tell us now the hypotenuse here is 37. They're giving us this value of the hypotenuse. And our job with these legs is to find the length of the side we don't know. So I'm going to name that. It can be A or B. Doesn't matter. If you want to use X even, that's fine too. So going back to our notes, remember we have that any leg, so A squared would be equal to the hypotenuse squared. So I'll call that C. C squared minus your B squared. So we're subtracting this time. So that means to find A, it's going to be 37 squared minus the other leg squared. Okay? And I'm going to do just like I did before, noting that the instructions say to find the exact length. So that means we are not rounding any decimals. So I'll come down here and type in, focus this a little bit for you again. All right, so 37 squared minus 35 squared, and I get 144. Oh, we should recognize that as a perfect square. When I take the square root of both sides, the square root of 144 equals 12. Square root of 144 is 12, so my A value is 12. So that's what I'm going to type in Delta Math. So we do exact length, and then we're going to exact length as an irrational value with the square root, and then rounded. So that's the order I'm going. So number 5, again, this says find the exact length. Notice the side missing is a leg. So this is number 5. So I'm going to draw my right triangle. And I'm finding the leg down here. So if you want to be consistent and label it A, that's fine. If you would like to use X, that's fine. What's going to matter is that your answer is correct. The work we expect to see is you setting up your equation. So again, hypotenuse squared equals, leg squared, so I'm trying to find A this time, will equal the hypotenuse squared minus the leg squared. I'll be real honest, my favorite is to just say hypotenuse squared like h squared. H squared equals L squared minus L squared. So if that's more helpful to you, you can. So A squared equals my hypotenuse squared, which is 4, minus the leg that I know, which is 3. And then y'all really can do some of this in your head. 4 squared is 16 minus 3 squared, which is 9. 16 minus 9 is 7. And then when I take the square root of both sides, my A will equal the square root of 7. So remember, if you get a radical that you could simplify, we're still not simplifying it. It's perfectly fine for you to leave it under the radical. So that's an exact length where we get an irrational value. And now, last one, it says find the length of the side to the nearest tenth, which means I'm probably going to get an irrational number. I just have to round. So for number 6 in my notebook, let me focus it for you a little bit. I'm going to draw in my right triangle. I have a leg of 4 and a hypotenuse 8. So again, I'm trying to find the measure of another leg. So just out of habit, I'll call that A. We'll let that be our B and our C. So again, C squared equals B squared minus A squared. So 8 squared, hypotenuse squared, is equal to the leg that we, did I write that? I wrote that incorrectly. My apologies. I'm finding the leg, which is A. So A squared equals hypotenuse squared minus leg squared. Which, if you don't like the ABC, you can literally just go leg squared equals hypotenuse squared minus leg squared. Like that. That's how I think about it anyway. So my A we don't know. My hypotenuse is always the first value here when I'm finding a leg. So 8 squared minus 4 squared. So if you feel confident with going, oh, that's 64 minus 16, you can. Or you can just use your calculator. So we'll do, let me make sure it's focused. 8, that's pretty good. 8 squared minus 4 squared, a little blurry, but 48. And remember, we are rounding to the nearest tenth. So when I take the square root of both sides, so I'm going to go in here and hit second x squared, and then 48. And I get 6.9. That's from right there. And that's what it looks like when I typed it in. So to the nearest tenth, 6.9. And we're good to go. All right, so like I said, it's set up so that numbers 7 and 8 are just like number 1. Numbers 9 and 10 are just like number 2, etc. So follow what they're like in your notes to help you out, and let us know if you have any questions. All right, good luck.